All right, so now we're taking a look at Learning Target 2, featuring the content from Glencoe 13.3. In this learning target, it'll be required that you recall your geometry knowledge, and we'll be applying our newly found knowledge on the unit circle. In example 1, I am to find the 6 trigonometric functions of theta, given that theta contains the point 5, negative 12. Well, an observation about 5, negative 12. That's going to be contained in the 4th quadrant because my x value is positive and my y value is negative. So what I decided to do is create a triangle where theta is going to be the angle in relation to the x-axis, okay? And this is just going to be a right triangle here. All right, well, 5 was the horizontal shift. So from going from the origin to this location, I went over 5 units, okay? The vertical shift that occurred was I went down 12 units. So we're going to say this is negative 12, okay? All right, so now we can use Pythagorean's theorem to identify the hypotenuse. And the hypotenuse is h squared is equal to 5 squared plus negative 12 squared. So the hypotenuse is equal to 25 plus 144. So h squared is equal to 169. If we take the square root, we get that the hypotenuse is 13. All right, so now we need to remember our SOHCAHTOA. So let's first start off with SO. SO means that the sine of angle theta is equal to the opposite over the hypotenuse. Well, opposite from theta is negative 12, and the hypotenuse we found was 13, okay? The friend of sine is actually going to be cosecant. Cosecant is actually going to be the reciprocal of negative 12 13. So cosecant is going to be hypotenuse over opposite. So we're going to get 13 over negative 12. All right, so now let's take a look at cosine. Cosine is ca, so adjacent over the hypotenuse. So the cosine of theta is equal to, well, the adjacent is 5 and the hypotenuse is 13. Well, the opposite, or my friend, of cosine is actually going to be secant. So secant is going to be the reciprocal of cosine, so we're going to be 13/5, because secant is really going to be the hypotenuse divided by the adjacent. Lastly, we have tangent, so we have TOA. So the tangent of theta is going to be equal to the opposite divided by the adjacent. Well, the opposite was negative 12 divided by the adjacent, which was 5. Okay. Lastly, now we're going to figure out the opposite of tangent. Well, the opposite of tangent is cotangent. And he's again going to be his reciprocal, which is me 5 over negative 12, or you can just simply say negative 5/12. All right, so looking at example 2, we're given 270 degrees and we need to find all 6 trigonometric values for this angle. Well, this angle is on your unit circle and it's one that I would expect you to remember. So 270 degrees, he is located right here. Okay, he'd have 2, 3, 90-degree rotations, okay? And the coordinates of 270 degrees, we have a 0 for our x, and y value is negative 1, okay? So one of the things that you learned with regards to the unit circle is that your x-coordinate is always your cosine, and your y value is always your sine, okay? So we already have 2 of our answers. The cosine of 270 degrees is equal to 0. The sine of 270 degrees is equal to negative 1. Now let's take a look at our other values. Well, tangent, okay, tangent of 270 degrees. Well, tangent is sine divided by cosine. So we'd have negative 1 divided by 0, which is undefined. It does not exist. And now we're taking a look at our other trigonometric values, okay? So secant, that's just the same as 1 divided by cosine. Well, our cosine value was 0. So 1 divided by 0 is, again, does not exist. It's undefined. If we're looking at cosecant, cosecant is 1 divided by sine, and our sine value was negative 1, and 1 divided by negative 1 is, well, negative 1. Lastly, we have cotangent. All right, so cotangent, he is really 1 divided by tangent, okay? And this is a little bit harder to see, but let's think about it. So tangent was really negative 1 divided by 0. And when we divide by a fraction, it turns into multiplying by the reciprocal. So this will turn into being multiplied by 0 over negative 1, which is 0. So notice that cotangent is actually defined for 270 degrees, and it's equal to 0. All right, so now we're going to take a look at our next example, example 3, where we are finding reference angles. Okay, so reference angles is just the textbook's fancy way of saying the same thing Miss Rudolph does of buddies. Okay, who is their buddy? AKA, how far away are they from the x-axis? Well, 300 degrees, when I start to rotate him, he's going to end up in our 4th quadrant. Okay, now I need to determine how far away is he from the x-axis. Well, it's important to recognize that this is 360 degrees, okay? And so how far away is 300 from 360? Well, that would be 60 degrees. So his reference angle is 60 degrees. Now let's do the same for part B, but now we're going to show a rotation of a radian. Notice that it's negative 2 pi over 3, so we're going to be rotating clockwise, okay? So this is normally 180 degrees. Well, 180 degrees would be pi, so this is going to be negative pi, which, to give you a little frame of reference for this guy, it'll be really negative 3 pi over 3. So we're going to be rotating about 2/3 of the way to getting to negative 3 pi over 3, which is why you can also use the logic to recognize that if we're 2/3 of the way there, we only have 1/3 of the way to go. So our reference angle for this guy will be pi over 3, because that's how many units away we are from, well, negative pi. All right, so now we're taking a look at example 4. Looking at A, this is actually a value that I would expect you to know at any given moment, but let's talk about why and how you could quickly analyze these things. So notice that 120 degrees, okay? He is in the 2nd quadrant, and he is 60 degrees away from the x-axis. That means that his reference angle would be 60 degrees, and we're going to share those values with 60 degrees. Well, sine is going to be the y-coordinate, and it's going to be the exact same as it is for 60 degrees in the 1st quadrant, okay? And the y-coordinate, or the sine value for 60 degrees, is radical 3 over 2. Therefore, the sine of 120 degrees is radical 3 over 2. All right, so now we're looking at B, so cotangent of 7 pi over 4. Well, 7 pi over 4 is really close to 8 pi over 4, which would be the 360 rotation, okay? So we know we're in the 4th quadrant. Now, because he is over 4, I know he's going to be one of my 45-degree buddies, and I also know that he's pi over 4 units away from 8 pi over 4, okay? Well, cotangent is 1 divided by tangent. So the first thing I need to think about, well, what is the tangent for my 45-degree buddies, okay? Well, in the 1st quadrant, tangent is equal to 1, okay? And in this 4th quadrant, tangent would be equal to negative 1. So we have 1 divided by negative 1 for 7 pi over 4's cotangent value, and we get a cotangent value of negative 1. All right, so now we're going to take a look at example 5, where I'm given a value in the 3rd quadrant for secant of theta, and I need to find the other remaining trigonometric functions. Well, it's important to recognize that secant, that's just the same as me saying 1 over cosine, and cosine is adjacent over hypotenuse, which is why the secant really is giving me the hypotenuse over the adjacent, okay? Which tells me that I essentially have my h and my a. My a is going to be 3, and my h is going to be 4, okay? And I'm also going to give myself a little reminder here. I'm over here in the 3rd quadrant, okay? Here's my angle theta. His adjacent is going to be negative 3, and then his hypotenuse is going to be 4. Then to figure out what the missing side length is, we'll just use the Pythagorean theorem. So we have x squared plus 3 squared equals the quantity negative 4 squared. So we have x squared plus 9 is equal to 16. If we subtract 9, we get x squared is equal to 7. So our leg is equal to the square root of 7. The other thing we need to recognize is the fact that because I'm in the third quadrant here, this leg is also going to be negative. So it's actually the negative radical 7 for the purposes of our unit circle. All right, so now let's figure out our missing values here. So secant's the opposite of cosine, so it's going to be very easy to first figure out cosine because cosine is the adjacent over the hypotenuse, and the adjacent was -3 and the hypotenuse was 4. Next, let's take a look at sine. Okay, so sine is going to be the opposite, which is negative radical 7, over the hypotenuse, which is 4. All right, the next standard trig function is tangent. So we have tangent of theta is equal to the opposite, which is negative radical 7, divided by -3, which just simplifies to being positive because we had a negative divided by a negative. We already have secant, so the next one that we can figure out is cosecant. And cosecant is the opposite of sine. So if I take the reciprocal, we're going to get -4 over the square root of 7. Well, you can't have radicals in your denominator, so you must rationalize the denominator by multiplying both the top and the bottom by radical 7, producing this expression as you see here. Next, let's do cotangent. So cotangent of theta, once again, we're going to look at the reciprocal, though, of tangent, reciprocal being 3 over the square root of 7. Rationalize our denominator, and we get 3 radical 7 over 7. All right, let's take a look at this next problem. It is a real-world problem, and actually your textbook has a really great picture, so I'd recommend taking a look at it. So we have this robotics arm, and it's going to rotate 135 degrees to complete this task. The robotic arm is 4 meters long, okay? This means this arm over here is 4 meters long, and this one over here is 4 meters long. And this angle of rotation is 135 degrees. So therefore, one of the other spots I can figure out is if I create this continuous line, this is essentially a 45-degree angle, reference angle here, okay? So what is this new position? Yes, I have a little typo. I just noticed that there, of this new arm. So we're trying to figure out this location here, okay? And so I'm just going to redraw my triangle that I'm really actually looking at. I'm looking at this 45-degree triangle, which would be a 45, 45, 90 triangle. And we're given that the radius of the arm is 4, which in this scenario is going to be the hypotenuse of this right triangle. With 45, 45 triangles, we know that our two legs are the same. So when we do Pythagorean theorem, we end up with 2x squared is equal to 4 squared, which is 16. And the reason I can do that is because x squared plus x squared is just 2x squared. Now we divide both sides by 2, and then we get x squared is equal to 8. Take the square root, and we get the square root of 8, which will simplify into 2 radical 2, okay? And so notice that the question asked me for the position of the arm, okay? And so I'm looking for essentially this coordinate right here, and because the horizontal is going to be the same as the vertical distance, we know that both are going to be 2 radical 2. Now the only thing I need to take into consideration is recognizing the fact that with a second quadrant placement, 135, we're going to have a negative x value. So it's actually going to be -2 radical 2, 2 radical 2.